Hi students, and welcome to my teacher channel. In the previous video we have discussed the basic operations on sets like union, intersection and difference. And now in this video let us try to solve the problems given in exercise 2.2 of sets chapter from the textbook of mathematics, Telangana state. Now let's do the first question. Here it is. If A is equal to set of 1, 2, 3, 4 and B is equal to set of 1, 2, 3, 5, 6, then find A intersection B and B intersection A. Are they equal? So let us first find the value sets and then comment on this one. Let's see here. First we need to find A intersection B, which is equal to, initially we have to write set A. What is set A? Set of 1, 2, 3 and 4. Intersection B. Now write set B. Set B is set of 1, 2, 3, 5 and 6. Now let me write the intersection of these two sets. Children, we have already seen intersection of sets is nothing but the set of the elements in common for both the sets. So which elements are in common? Let's see here. 1 is common in both the sets. 2 is also common in both the sets. 3 is also common, but not 4 and other elements. So set of only the common elements, let me write here, or list here, 1, 2 and 3. Now this is A intersection B. Now let's find B intersection A. Now B intersection A, where we need to write set B initially and then set A. Now what is set B? Set B is set of 1, 2, 3, 5 and 6. Intersection A. Now A is set of 1, 2, 3 and 4. So just interchange the sets. Now find the intersection. So intersection of two sets, we know already that the set of elements in common. What are the set of elements in common? Now 1, 2 and 3. Yes, these are the elements in common. Now let's see the set of A intersection B and B intersection A, both are equal. Set of 1, 2, 3 and set of 1, 2, 3. So what you can comment on this? Are they equal, he is asking. Yes, they are equal. Therefore, A intersection B is equal to B intersection A. Now, let us see the second question from this exercise, and it is like this. If A is equal to set of 0, 2 and 4, find A intersection 5 and A intersection A. So two things we need to find. One is A intersection 5. 5 is null set or empty set that we already know. And A intersection A. These two let us find, and in the end let us comment on the result. Now let's see here. First we'll start with A intersection 5. A intersection 5 means null set. Let me write A first. Set of, what are there in A? 0, 2 and 4. Intersection 5. 5 is null set or an empty set. So that means a set with no elements. So let me write an empty set here with no elements in it. Right. Now, intersection of two sets is nothing but the set of common elements. Now tell me which element is common in both the sets. 0, 2, 4. Which one is common? So here it is very clear that there is no element in common, because here it is empty set. So no element is in common. That's why the intersection is again an empty set, which means we can conclude that A intersection 5 is equal to empty set. 5 again. So this is what we can comment on this. Let me find A intersection A. A intersection A is equal to set of, what is set A? 0, 2, 4. Let me write. Intersection of, again A, means same set again. 0, 2, 4. So what are common in both the sets? It is quite natural, both are set A only, so all the elements will be common. 0, 2 and 4 are common, right? Now set of 0, 2, 4 is nothing but A. So we can comment on this result like this. A intersection A is equal to A again. Now let us do the third problem, and here it is. A is equal to set of 2, 4, 6, 8 and 10. B is equal to set of 3, 6, 9, 12 and 15. Find A minus B and B minus A. So we need to find both A minus B in the beginning and then B minus A. Now let's start with A minus B. Now first let me write set A, and what elements are there in set A? Set of 2, 4, 6, 8 and 10 minus B. Now we have to write the elements of set B. So set of 3, 6, 9, 12 and 15. Now children, what we need to do now? We need to find the difference of set A and B. We have seen in our previous video what is the difference of sets. So difference of sets is nothing but the set of the elements which belong to the first set but not the second. Means the elements of set A but not B. But not B means we need to cancel the common elements. So let me see here which elements are in common. 2, 4, no, 6 is the common element in both. Let me cancel that. 8, 10, not common. Now let me write the difference of A and B is the set of elements in A but not in B. So only the elements in A. So what elements are there in only A? 2, 4, not 6, 8 and 10. Now this is A minus B. Now let us do B minus A. Right. So children, we know that we need to start with the set B now. What is set B? Set of 3, 6, 9, 12 and 15 minus A. Now we have to write set A. What is set A? 2, 4, 6, 8 and 10. Now we have already seen what is the difference of sets. Difference of sets is nothing but the set of elements which belong to the first one but not the second set. Means the elements of B but not the elements of A. So not the elements of A means we need to cancel the common elements. Now the common element will be 6. So only the elements which are there in the first set, that we have to write. Set of 3, 9, 12 and 15 are the elements which are there in B minus A. Now let us check both the answers. A minus B answer and B minus A answer. Are they equal? Set of 2, 4, 8, 10. Set of 3, 9, 12, 15. They are no way equal and there is not even a single common element. Means these two sets are clearly disjoint sets. Now let me write here, therefore A minus B is not equal to B minus A. Children, here is one interesting question. Now it is like this. If A and B are two sets such that A is subset to B. So and this symbol we have already seen, discussed in the previous video, that this is symbol for subset. So A is subset to B. Then what is A union B? So the condition is A is subset to B, and we already discussed that what is a subset. Subset is a set in which all the elements of set A must be the elements of set B. All the elements of set A must be the elements of set B. So then what is A union B that we need to find? Now let us try to find that one. See here, let me take a universal set, and we know that rectangles are generally used to represent a universal set mu, and A is a subset to B. Now A set let me take, and this is a subset to B. So if A is subset to B, then naturally B must be bigger set, because every element of A is an element of B. If I take any element here X, so X belongs to A and X also belongs to B, then A is a subset to B. Now what we need to do? We need to find A union B. Now let me write or shade the A union B. What is union of sets? Union of sets is nothing but the set of all the elements of A and B. Now set of all the elements means we have to shade the whole regions of A and B. Yeah, let me shade that. So if I shade B, then automatically A is also shaded, because A is a subset. Now A and B, all regions are shaded. Now the union, again we are getting the union of A and B again as B only. So A union B is equal to B when if A is a subset to B, then A union B is B. Now let us move to fifth problem. Now the problem is like this. Let A is equal to set of X such that X is a natural number. Children, here the sets are given in their set builder form, where the property of the elements will be given, but not all the elements are listed like roster form. Now here A is equal to X such that X is a natural number. So let me convert all these sets into roster forms. So given sets in roster form, so that it becomes easy for us to find unions, intersection or difference. Now A is equal to set of X such that X is a natural number. So what are natural numbers? That we already know that natural number starts with 1, 2, 3, 4, 5, 6 and so on. There is no end. Right. Now this is set A. Now set B, let me convert that set builder form into roster form. So what is set B? Set of X such that X is an even natural number. So we have to write even natural numbers in set B. Even natural numbers, what are they? 2, 4, 6, 8, so on. Now they are all even natural numbers. Now set C. X such that X is an odd natural numbers. So what are odd natural numbers? Which are not even, they are all odd. 1, 3, 5, 7 and so on. These are all odd natural numbers. Now set D is equal to X such that X is a prime number. So we have to write or list the prime numbers in set D. What are prime numbers? 2 is the first prime number in natural numbers. 2, 3, 5, 7, so on. Now, let us solve the questions that they have given: A intersection B, A intersection C, A intersection D, B intersection C, B intersection D, and C intersection D. All these things we need to find. Now, let me start with A intersection B, which is equal to A is set of, what is A? Set of 1, 2, 3, 4, 5, 6, so on is the set. So it is an infinite set. Intersection B. What is set B? Set B contains 2, 4, 6, so on. Now let me find the intersection of these two. We already know that the intersection of sets is nothing but the set of elements which are in common. So set of common elements. What elements are common? 2, 4, 6. So from natural numbers and even numbers, if you compare, the common numbers are obviously even numbers only. So 2, 4, 6, 2, 4, 6, so on are the common elements. Means A intersection B is set of 2, 4, 6, so on. What are they? Set of 2, 4, 6 are even natural numbers. What are they? Even natural numbers. So we found A intersection B. Now let's see A intersection C, the second one. A intersection C. So we have to write set A initially. What is set A? Set of natural numbers 1, 2, 3, 4, 5, 6, so on. Intersection. And C. What is C? C is the set of odd natural numbers. Set of odd numbers. What are odd numbers? 1, 3, 5, 7, and so on. Now, what elements are in common for A and C? A is set of natural numbers and C is set of odd numbers. Obviously, all these odd numbers are there in natural numbers. So, odd number set is a subset to natural numbers. That means, what elements are common? Now, let's see here. Set A, 1 is common, 3 is common, 5 is common. So, set of 1, 3, 5 and so on. Set of 1, 3, 5 and so on are all odd natural numbers. Odd natural numbers. Now, we need to find A intersection D. So, let me write here. A intersection D is equal to set of A. A is set of natural numbers. What natural numbers are there? 1, 2, 3, 4 and so on. Intersection D. What is D? D is set of prime numbers. So what are prime numbers? Set of 2, 3, 5, 7 and so on. Now let me write the intersection of these things. So what are common in both the sets? 2 is common. 3 is common. Obviously 5 is a natural number. 7 is a natural number because A is natural number set 1, 2, 3, 4, 5, 6, 7 and so on. So 2 is common, 3 is common, 5 is common, 7 is also common. So 2, 3, 5, 7 and so on, which is nothing but all these are again are the prime numbers. That means we can understand one thing from this, because D is prime numbers set, A is natural numbers, and we know that D means prime numbers are subset to natural numbers. Then the intersection is always the subset one only, that means D only. Now let's do B intersection C. Let me write set B first. What is set B? Set of even numbers, even natural numbers, 2, 4, 6 and so on. intersection C. What is set C? C is set of 1, 3, 5, 7. That means odd natural numbers. 1, 3, 5 and 7, so on. Now let us see the intersection of these two. Intersection is the set of all the elements in common elements set. So which element is common? 2, 4, 6. No element is common. Why? Because all even numbers and odd numbers, there will be no element in common. So the intersection is obviously an empty set. So we can conclude like this: B intersection C is 5, means a null set. Now we have to solve B intersection D. B intersection D. Let me write set B first. What is set B? B is set of even natural numbers. What are even natural numbers? 2, 4, 6 and 8, so on. Intersection D. What is set D? Set D is set of prime numbers. What are prime numbers? Set of 2, 3, 5, 7 and so on. Now, even numbers and prime numbers. What is the intersection? Means common element in both even and prime. We know there is only one even prime, that is 2. So 2 is the only element which is in common from these two sets. No other element will be common. So it will be set of 2. The last one that we have to find in this problem is C intersection D. Let me write here C intersection D. What is C? C is set of odd natural numbers. What are odd natural numbers? 1, 3, 5, 7 and so on. Intersection D. What is D? D is a prime number set. So what prime numbers are there? 2, 3, 5, 7 and so on. Now, out of these two sets, what elements are in common? That we have to write as intersection. One is not common because one can be an odd number but not prime number. One is not a prime number. 3, 5, 7. 3, 5, 7 are common, so on. So like this, we can find the intersections of sets. Let us solve the sixth problem from this exercise. And in this problem, it is given that A is set of 3, 6, 9, 12, 15, 18 and 21. B is set of 4, 8, 12, 16, 20 and C is equal to set of 2, 4, 6, 8, 10, 12, 14 and 16. And of course, D is equal to set of 5, 10, 15 and 20. Now, here is a big list of the things that we need to find. A minus B, A minus C, A minus D, like this, 10 differences that we need to find. Children, need not to worry, let the number be 10, but it is only the difference of sets that we need to find. Now, let us start the first one. A minus B. Let me do here A set of 3, 6, 9, 12, 15, 18, 21 minus B. What is set B? Let me write here 4, 8, 12, 16 and 20. So difference of sets is nothing but we have to write the elements of the first set but not the second one. So X must belongs to A but not B. So what elements are there? To write that one, if B should not be there, that means we have to even cancel the common elements. What elements are in common? 3 is not there, 6 is not there, 9 of course not there, 12 is the common element. Let me cancel that. 15 not there, 18 is also not there, 21 is also not there. Now only elements of the first set, because minus B, we need not to write the second one. So elements of the first set is 3, 6, 9, 15, 18 and 21. This is A minus B. That's it. We got the difference. Now let's go for the second one. Second one is A minus C. So let me start writing set A. What is set A? Set of 3, 6, 9, 12, 15, 18 and 21 minus C. What is C? C is set of 2, 4, 6, 8, 10, 12, 14 and 16. Now A minus C means the elements which are there only in A but not in C. So only A. So common elements we need to cancel. What are common? 3 is not common. 6 of course is common. Let me cancel that. 9 not. 12 is common. Cancel. 15 no. 18 is no. 21 no. Okay. Now only elements. The elements which are left in the first set that we need to write. 3, 6 is cancelled anyway, 9, 15, 18 and 21. Now this is A minus C. Now let's do A minus D, the third one. So let me write set A now. Set A is set of 3, 6, 9, 12, 15, 18, 21 minus D. So what is D? D is set of 5, 10, 15 and 20. They are all multiples of 5. Now let me find the difference. So what we have to do, the first step, cancel the common elements. 3, 6, 9, 12, 15 is the common element. 20 is not there. Okay, that is the only common element and we cancelled. Now the answer will be the elements which are left in the first set. So what elements are there? 3, 6, 9, 12, 18 and 21. That's it. And we are not writing that one because we have to subtract them. Difference we have to write. So this is A minus D, the third one. Now let's solve fourth one, which is B minus A. So first we need to write set B. Set B. B is the set of 4, 8, see there the elements 4, 8, 12, 16 and 20 minus A. A is the set of 3, 6, 9, 12, 15, 18 and 21. These are multiples of 3 and now these are multiples of 4. Now subtraction, let us see which elements are in common. That is the first step. We have to cancel the common elements. 4, 8, no. 12 is the common element. Now 16 is not there, 20 is not there. Now what we have to write then? B minus A means we have to write the elements of B but not A. Elements of B which are not in A. 4, 8, 16 and 20 is the answer. B minus A. So children, we have found up to B minus A. Now the fifth one, C minus A is equal to, let me write set C. C is the set of 2, 4, 6, 8, 10, 12, 14, 16. So these are all multiples of 2, right? Minus A. A is set of 3, 6, 9, 12, 15, 18 and 21. Now what is the first step? First step is to cancel the common elements and second step is to write the elements which are left only in the first set. Okay, now let's do here. Cancel the common elements. So 2, 4, 6 is the common element in both. 8, no. 10, 12 is the common element. 14, no. 16, no. Now second step is to write the elements which are left in the first set. So what is that? 2, 4, 8, 10, 14 and 16. This is C minus A. Let's go for the sixth one. See children, it may look long but it is pretty easy to solve. Sixth one, D minus A. First we need to write set D. So what is set D? Set D is the multiples of 5. 5, 10, 15 and 20 minus set A. Set A is the multiples of 3. 3, 6, 9, 12, 15, 18 and 21. Now what is the thing that we have to do? Cancel the common elements and list only the elements which are left in the first set. Now cancel the common elements. 15 is the common element. Yes, that is the only common element left. Now what elements are left in the first set? 5, 10 and 20. That's it. Now this is D minus A. Seventh one, B minus C. So children, we know what we have to write. First, set B. What is set B? 4, 8, 12, 16 and 20. These are multiples of 4. Minus C. C is the set of multiples of 2, I think, right? 2, 4, 6, 8, 10, 12, 14 and 16. The first step is to cancel the common elements. So let me cancel common elements. 4 is common, 8 is common, great. 12 is also common, wow. 16 is also common. Then what the element left in the first set? Only one element left in the first set, and that is 20. So B minus C is a set with single element. So it is a set with single element. Can also be called as singleton set. And a set with one element is called a singleton set. Now let me go for eighth one. Eighth one is B minus D. So let me write set B. We have already written here 4, 8, 12, 16 and 20, which are multiples of 4, minus D. Set D. Set D are the multiples of 5. Let me write that. 5, 10, 15 and 20. Now we need to, first step is to cancel the common elements. What elements are in common? 4, 8, 12, 16. No, only 20 is the common element. So what elements are left in the first one? 4, 8, 12 and 16. We are not writing 20 because minus D. So 20 is an element of D also. We are not writing that one. Now ninth one, last but one, C minus B, which is equal to C minus B. C is the set of multiples of 2, 4, 6, 8, 10, 12 and 14, 16, up to 16 only, minus B. B is set of 4 multiples, 4, 8, 12, 16 and 20, up to 20 only, right? Now cancel the common elements and list the elements left in the first set, right? So 4 is common, great. 12, 8 is also common, right? 10 not there, 14 not there, 16 is common, right? Now the elements in the first set are left in the first set. 2, 6, 10 and 14. Now the last one from this bit is to find D minus B. Let us do now. D minus B is equal to, first let me write the set D. What is set D? Set D is the elements of multiples of 5. 5, 10, 15 and 20 minus B. What is B? B is the set of elements which are multiples of 4. 4, 8, 12, 16 and 20. Now what is the first step? Is to cancel the common elements. Second step is to write the elements left in the first one. Now what elements are in common? 5, 10, 15? No, only 20 is the common element. And what elements left? 5, 10, 15. Let us solve the last bit from this exercise, and that is State whether each of the following statements is true or false. Justify your answers. So in this bit, he has given 4 statements. Now we have to state whether the statement is true or false. If it is true, why? Or if it is false, why? The justification for our answer has to be written. So let us start with the first one. Here is the statement. Set of 2, 3, 4, 5 and set of 3, 6. So two sets are there, are disjoint sets. So here he is saying the sets are disjoint. So these two sets are disjoint. That is the statement given. So before writing true or false, let us try to understand what is a disjoint set. We have already seen in our previous video of the basic operations on sets that the disjoint sets are the sets where there is no common element present. Means if two sets are there and in both the sets there is no common element present, then we can say that those two sets as disjoint sets. Now let's see whether these two are really disjoint or not. So let us see, is there any element common? 2, 3. Yes, children. 3 is the common element present in both the sets. So there is a common element in both sets. That means they are not disjoint, but the statement is saying that it is disjoint. So the statement will be false. Yes. So the answer is false. We should not just simply write false. We have to justify our answer. Why this statement is false? We have already discovered why it is false. Because these two sets have an element 3 in common. Because the sets have element 3 in common. Okay, now that is the answer for the first one. Now let's see the second statement. Set of A, E, I, O, U. This is the set of vowels of English alphabet, and set of A, B, C, D. Now this is the set of first 4 alphabets of English letters, are disjoint sets. So here again he is saying that the sets are disjoint. The condition for disjoint sets that there should be no element in common. Let us check. A and A is common in both. Yes, only one element. So A is common in both the sets. So obviously they are not disjoint. But the statement is saying that it is disjoint. That means even this statement is also false. So let us write here. This is also false. Why? Because same thing. The sets have element A in common. So both sets have element A in common. That makes the statement false. Now let's go for the third statement. What is this saying? Set of 2, 6, 10, 14. There are some numbers as elements in this set. And set of 3, 7, 11 and 15 are disjoint sets. Now let us check whether there is an element in common or not. See, 2, 6, 10, 14. No. Yes. Here these two sets have different elements and there is not even a single element in common. So obviously these two sets are disjoint sets. That means the statement is true. So let me write here. Third one is true because there is no element in common in both sets. Right. Now the last one, fourth one. Set of 2, 6, 10, set of 3, 7, 11 are disjoint. 2, 6, 10, 3, 7, 11. Yes, there is no element in common. That means Even this statement is also true as there is no element in common. True as there is no element in common. Right. So children, this is about the exercise 2.2 from the chapter Sets from Telangana Mathematics textbook of 10th class.